In this part, we're going to focus on simplifying with cube roots. So, since I mentioned that we're simplifying with cube roots, that means that we're going to be using different numbers compared to when simplifying with square roots. So the different numbers I'm talking about are the ones located over here. So the one in red, 8, 27, 64, 125, 216, and 343, those are called perfect cubes. So we're going to be using those numbers. In the last part, in the previous examples, in the previous sections, when you're simplifying with square roots, we're using perfect squares. Now over here, we're going to be simplifying with cube root. And the reason that we know we're working with cube roots, or the third root, is here at the index, it's a visible 3. So if you have a visible 3, that means you're working with the cube root, or also known as the third root. Meaning we're going to be using the numbers that are wrote here in red. So let's take a look. We have 4, the cube root, or the third root of 16a to the 20th power, b to the 16th power. So in this example, we now have two variables. It's going to be similar to the previous example we did when simplifying with square roots of numbers and variables. So just like before, I want to break it into the numbers and their respective variables. I'm still going to have the 4, but now I'm going to have the cube root of 16. Since we do have a visible 3, that means that we have to have the index 3 on each radical. The reason is because you cannot have two radicals of different index, meaning you should not have a cube root, and if you don't write a number here, that means you're saying you're working with square roots. That cannot be next to each other unless the problem involves with different radicals in the beginning. In this example, we started with cube root, that means all radicals have the 3. So I have 4, the cube root of 16, the cube root of a to the 20th, and the cube root of b to the 16th power. So just like before, we're going to separate this 16. Now it's not a perfect cube, but one of the numbers in red can go into 16. The most logical choice would be the 8. 8 can go into 16 2 times. So I'm going to have the 4 still in front, but now I'm going to break 16 into 8 and 2. And again, they both have the cube root. Remember to include your index on the radical. Next, I'm going to simplify the cube root of a to the 20th power. Now, the question would be, just like before, the index, which is 3, can 3 go into 20 as a whole number? In this case, it cannot. So that means I'm going to break a into 2 a's. So let's start off with 20 and count down. If I take 1 away, I have 19 left. Can 3 go into 19 as a whole number? Then, in that case, no. So instead of taking 1 away, I'm going to take 2 away. So if I take 2 away, I have 18 left. So the question is, can 3 go at an 18? In this case, yes. So I'm going to write 18. Then the amount that I took away, which is 2, I'll put it on the second A. So now I'm going to have the cube root of a to the 18th power and the cube root of a to the second power. Next is b to the 16th power. So my first question is, can 3, my index, go into 16 as a whole number? In that case, it cannot, so I'm going to split the b into 2 b's. So, starting off with 16, counting down, if I take 1 away, I have 15 left. Can 3 go into 15 as a whole number? In that case, yes. So I'm going to write 15. Then I'm going to take the 1, I put it on the second b. So this is the cube root of b to the 15th power while this is the cube root of b to the 1 power. Now I broke up into many parts, and then we're going to identify which one that we can do the cube root of. So here, you're still going to have the 4 in front. I can do the cube root of 8, which is 2. So if I do the cube root of 8, the base is 2. You cannot do the cube root of 2 because none of the red numbers is 2, so I'm just going to bring it down. And again, I still have that index of 3. Now let's take a look at the a's. We can do the cube root of a to the 18th power because 3, my index, can go into 18 6 times, so I'm going to have a to the 6th power. Now, the cube root of a squared, 3 cannot go into 2 as a whole number, so I'm just going to bring it down. Remember to include your index. Now for the b's. You can do the cube root of b to the 15th power because my index 3 can go into 15 5 times, so it's going to be b to the 5th power. Whereas the cube root of b to the 1 power, 3 cannot go into 1 as a whole number, so I'm just going to bring it down. Like so. Alright, from there, we're going to start simplifying. Finalizing our final answer here. This is 8. So 4 times 2 is 8. The ones that are without the radical, meaning the 8, the a to the 6th power, and b to the 5th power will be in the front. So I'm going to write 8, a to the 6th power, b to the 5th power. Now the ones with the radical, in this case the cube root, the 2, the a to the 2nd power, and the b to the 1 power will be in the back side, but they're going to be together inside one radical. So 2, a to the 2nd power, and then b, all inside the cube root. Make sure to include your index because that's what we start off in the very beginning. So my final answer is 8, a to the 6th power, b to the 5th power, the cube root of 2a to the 2nd power, b. And then let me box that final answer. Now for this process, I broke it down into the number respectively, the a respectively, and then the b respectively, because once you break it into simpler parts, it's easy to work with each individual parts, so that way you can identify which one that you can do the cube root and which one you cannot. So that way you can identify that the ones that you were able to do the cube root will be in the front, the ones that you cannot will be in the back. In this example, we have -5, the cube root of 81, n to the 25th power, n to the 14th power. Again, we know that we're working with the cube root, or the third root, because we have the visible index of 3. Now just like before, I'm going to split it into the number, the m, and the n respectively. So we're still going to have the -5 outside, but I'm going to have the cube root of 81, the cube root of m to the 25th power, and then the cube root of n to the 14th power. And again, they're multiplying to each other. So let's focus on the number first, the cube root of 81. So I'm still going to have the -5 out on the outside, but the cube root of 81, none of the red numbers are exactly 81, so that means the next question is which of the red numbers can go into 81. In this case, it would be 27. So we're going to have 27 times 3. 27 times 3 will be 81, and each of them, the 27 and the 3, will have the cube root. Alright, next is the m to the 25th power. The first question is, can 3, my index, can go into 25 as a whole number? In this case, it cannot. So you're going to break it down into 2 m's. So, starting with 25 and counting down, if I take 1 away, then I'm going to have 24. So the question is, can 3 go into 24 as a whole number? The answer is yes. So I'm going to write 24 on the first m, and then I'm going to write 1 that I took away on the second m. Both of them have the cube root. Next is the ends. The first question is, can 3 go in 14 as a whole number? The answer is no, so I'm going to write 2 ends. So counting down from 14, if I take 1 away, I have 13. Can 3 go into 13 as a whole number? In that case, the answer is no. So instead of taking 1 away, I'm going to take 2 away. So I'm going to have 12 left. So can 3 go into 12 as a whole number? The answer is yes. So I'm going to write 12 on the first end. And I'm going to write 2 that I took away on the second end. And then I'm going to put my cube roots on the ends. So there's the numbers, the m's, and the n's split into their respective parts. Alright, so let's focus on simplifying. Again, I still have the -5. The only one that you can do the cube root of is the 27. The cube root of 27 is 3. The cube root of 3, you can't do the cube root because none of it is equal to, none of the red numbers is exactly 3, so I'm going to bring down cube root of 3. And it's still multiplying. Next, let's look at the m's. So the first one, the cube root of m to the 24th power, we can do the cube root because 3 can go into 24 8 times. So that means it's going to be m to the 8th power. The second one, 3 cannot go into the 1 power, so we're just going to bring down exactly what we have, which is the cube root of m. Now for the ends part, the first one, you can do the cube root of n to the 12th power because 3 can go into 12 4 times. So we're going to have n to the 4th power. Now the second one, 3 cannot go into 2, the second power, so we're just going to bring down what we have. So that means the cube root of n squared. So now we're going to put the ones that we were able to simplify, meaning the cube root. But first, I need to do -5 times 3, which is -15. And then the ones that are without the cube root, -15, m to the 8th, n to the 4th, they will all be in the front, so -15, m to the 8th power, n to the 4th power. And the ones with the cube root, the 3, the m, and the n squared, will be all together. So 3, m, n squared, all inside 1 cube root. So that would be my final answer. Let me box that up. Now, just like before, broke it down into the 81, the m, and the n, then separate the 81 into 27 and 3, separate the m into m to the 24th, m to the 1 power, separate the n into n to the 12th power and n to the 2nd power, and then I look at it at each individual part to see which one I can do the cube root and which one I cannot. Then simplify -5 and 3, which is -15, and then put everything that's without the radical in the front, in this case without the cube root, and then the ones with the cube root, the 3, the m, and the n squared, I put it in the back, and then hence we have our final answer.